Jai Hind students. In the previous lecture of satellite communication, we started about discussing about satellite subsystems. When we are discussing about satellite subsystem, then the picture come into our mind that a satellite have various systems or blocks to perform specific task, and the individual task of a specific system will govern a specific area of the satellite, such as attitude or orbit locations of the satellite or power requirement of the satellite. So, all these subsystems we have to identify one by one and studied one by one. In the previous one, we understand about the AOCS. In the previous one, we understand about the AOCS and TTCM. AOCS basically related with the satellite attitude and orbit location. This system is actually generating the data and taking the necessary action to maintain the satellite in its orbit and at a particular attitude. TTCM is telemetry tracking and command and monitoring subsystem, which is actually directly connecting the satellite with the earth station to monitor various parameters as well as for the tracking and telemetering data of the satellite. For tracking, we are using the AOCS data. For telemetry, we are using the sensors data which are located on the satellite for various monitoring of the various parameters such as flow and the pressure and the temperature of the satellite. Similarly, in this lecture, we are concentrating on these two parts. These are power subsystem and antenna. When we are launching a satellite into the space, basically we are using rockets. Rockets have thrusters, multi-stage thrusters, and that thrusters are giving the rocket the required boost to get the escape velocity so that a satellite can escape the earth atmosphere and can be placed in the satellite orbit. It means for the initial setting, we have rocket thruster for the power, as well as satellite will placed in the satellite orbit. To initiate initial systems, we required some kind of power, and that power is given by the fuel which is already present on the satellite or rocket subsystem. But after placing the satellite in the orbit and when satellite is in working condition, there is a continuous requirement of the power for the satellite working and its various block. As I told you in the previous lecture, satellite is orbiting around the earth and continuously changing its position. Sometimes satellite is in between the earth and the sun. At that time, temperature of the satellite is quite high. But when the satellite is just behind the earth, means in the shadow region, at that time satellite temperature will be going quite down. Means if your systems on the satellite have to work, they have to work in these harsh temperature conditions. That's why some air conditioning unit type structures are required at the satellite to maintain the stable temperature inside the satellite. At that air conditioning system also required the power to operate. Similarly, there are various components also. They are generating the data, sending the data, receiving the data. That's why they also required power to operate. And also whenever your satellite it is losing its altitude or orbit location, also power is required to on the thrusters or flywheels to maintain their satellite in the orbit. It means power plays an important role in the satellite operation. So when we are talking about the satellite power, power is mainly generated by the solar power system and the batteries. For a satellite, when we are launching a satellite, if you know the basic thing, that 50% part of a satellite system is mainly constituting the fuel part, so that satellite can maintain its orbit. But for the continuous requirement, you cannot rely on this 50% fuel part. You have to use some onboard renewable energy so that you can operate the satellite in the space easily and without any discrepancies or any other problems. So in that part, we have solar power system. That solar power system actually has the solar panels. That solar panels are opened at the time after the insertion in the orbit of the after the insertion of the satellite in its orbit. These solar panels are continuously taking the solar energy and converting it into the electrical energy. This electrical energy is stored in the batteries, and that batteries are providing that power to the satellite systems continuously when the satellite is in the shadow region. Means this complete power requirement is solved by these mainly solar power systems and the batteries. So this is the power subsystem of a satellite subsystem. Now next part is satellite subsystem, that is antenna. Actually you can call the heart of the satellite is its transponder and its communication system. Means heart of the satellite is its transponder, and transponder is basically sending the data and receiving the data. But for the sending and receiving, we require the antenna. So antenna plays an important role for the operation of the satellite. So when we are talking about the antenna, basically what is an antenna? Antenna is a device that provides a transition between guided electromagnetic wave in wire and electromagnetic waves in free space. Means antenna is a electronic device. Whenever you are feeding any type of electrical signal or AC power to that conducting wire or electronic power wire, then that power will be radiated in the form of electromagnetic waves in the free space. This is the basic concept behind the antenna working. You also know that antenna use the reciprocity theorem for its operation. So when we are talking about antenna, these are some examples of the regular antenna which you can see, such as this is Yagi-Uda antenna, these are patch antenna, these are antenna array, these are parabolic reflector antennas, this is dish TV antenna which is also parabolic reflector antennas. These all are the antennas. But when we are talking about the satellite system, we have some specific frequencies and band. Means we have these ELF, SLF to visible spectrum, EHF range. These all frequency band are present. But out of these frequency bands, only this SHF, super high frequency, which is from 3 to 30 gigahertz, is used for the satellite link. It means that is divided into, as per the previous discussion, LSC, X, KU, K and KA bands. These all bands are used for the satellite communication, and the specific antenna which can work for these bands are very specific, and that antennas are wire antenna, horn antenna, array antenna and a reflector antenna. So when we are talking about the satellite antenna, means we are using these four kind of antennas. Other than these, one antenna, that is helical antenna, that is also used for the communication part, but this helical antenna is mainly used for deep space missions. Every satellite have these wire, horn, array and reflector antennas. Now, how you are going to select these type of antennas for a individual satellite? So basically, any antenna have some fundamental parameters. That parameters are frequency band for which that antenna is going to be used. The radiation pattern means the two or three dimensional representation, graphical representation of the field strength. Means if you are placing a dipole antenna on this position and you are getting the radiation pattern, means in this direction, means perpendicular to the placement of the satellite, antenna, you are getting the maximum radiation. So this is the radiation pattern of an antenna. Similarly, the field region, the directivity, the efficiency and the gain, beam width, side lobes, these are called side lobes. These are the lobes, main lobes, and if we are having some kind of other lobes, that is side lobes. Similarly, impedance of the satellite, bandwidth, which kind of polarization is used by the antenna, because when we are talking about the transponder, then right hand circularly polarized, left hand circularly polarized individual antenna are used for specific beam operation. Because when your satellite is used for the transmission and receiving, you can easily identify one point, that sometimes satellite antenna have to transmit data on a large region, then it will use a wide beam antenna. But when you want to cover a specific area, then you required a spot beam, and that spot beam is required specific information about the polarization, and that's why this polarization parameter is also very important during the selection of the antenna in satellite system. Similarly, other points are effective aperture, antenna temperature and all that point. So these all are the fundamental parameter which are required for the selection of the antenna for a satellite. So starting from very first, that wire antenna, when we are talking about the wire antenna, we are starting from the dipole antenna. Dipole antenna is the simplest type of antenna of a communication system, and in this system we have two poles or into which radio frequency current flow. You can see in this diagram, we have this conducting wire of lambda by 2 length. It is fed by the transmission line with the 73 ohm radiation resistance. Then the current and the associated voltage causes an electromagnetic or radio signal will be radiated. Means when you are going to apply that transmission line power to this antenna, a magnetic field will create. That current magnetic field will create a current and voltage distribution through this throughout this lambda by 2 length, and that will create a electromagnetic or radio signal that will be radiated. As per the reciprocity theorem, if you are placing this antenna or the dipole antenna in a specific electromagnetic field, then it will again generate the voltage at the output of the transmission line. It means that dipole antenna will be used for both transmission as well as receiving. Then the dipole is generally taken to be an antenna that consists of a resonant length of a conductor cut to enable it to be connected to the feeder. That is basically related to the designing of dipole antenna. Then the dipole antenna more structure, that are when multiple half wavelength dipole are used, they are similarly normally feed in the center. Means by in the multiple of lambda by 2 you can make the various dipoles. Means if you are using 2 dipole, it will become a lambda length antenna. If you are using 3 lambda by 2 dipoles, then it will become 3 lambda by 2 antenna. And you can see that these all will give different kind of radiation pattern, as this radiation pattern is for the 3 lambda by 2 antenna, this is for the lambda by 2 antenna, this is for the lambda antenna. It means every time its radiation pattern will be changed, and that is as per the requirement of the satellite you can use the available dipole antenna. Then these are some specific points related to the dipole antenna, because during the answering question in the university exam you required these points, that the dipole antenna is particularly important from form of a RF antenna which is very widely used for radio transmitting and receiving application. Also the dipole is often used in its own as an RF antenna, but it also forms the essential element in many other type of RF antenna. Also it is the possibly the most important form of RF antenna, and dipole have a radiation pattern shaped like a toroid or donut, symmetrical about the axis of the dipole. So it means the radiation of the maximum at right angle of the dipole dropping off to 0 in the antenna axis. You can see in this diagram. This is the antenna axis. Here the radiation pattern in power is minimum. You can see that the radiation is minimum, but in this perpendicular direction radiation is maximum. Then this is the 3-dimensional radiation pattern for a dipole antenna. You can see that this is a donut type structure. This is the antenna placement. This is the perpendicular side. This is the antenna axis, and the radiation is minimum in this direction and maximum in this direction. So this radiation pattern will greatly help for the dipole selection of the antenna in the satellite. Then the types of dipole antenna which is used by the satellite, that are short dipole, that is somehow less than lambda by 2, means lambda by 4. Between lambda by length is between lambda by 2 and lambda by 4. Similarly, half wave dipole, quarter wave monopole, basically lambda by 4 is called quarter wave monopole, and the folded dipole. Folded dipole is basically made by folding a, what we will do, we use 2 individual lambda by 2 length antenna and join them through the end, and between them there is a point where we feed the transmission line, so that dipole antenna will can receive or transmit the signals. So these are the various wire antenna used by the satellite for the satellite transmission and receiving data. But for the other ranges which are, as you know, that in the satellite basically all operations are worked in these 3 bands, Ku, K and Ka. S, Ku and Ka band. For S band you can use wire or some kind, but for the Ku and K you are basically using these microwave antennas. That horn antenna, antenna array, reflector antenna are related to microwave antenna, Antenna array is somehow also related to the wire antenna, but in broadly you can identify one point that antenna array is group of antenna, various kind. What you are doing, you are taking various antenna of similar structure and making a group of that antenna to increase the directivity and gain of the antenna. It means if you are taking a lambda by 2 monopole and a dipole antenna, and if its directivity and gain is not as per the requirement of your system, you can make a group of array, a group of antenna to increase the directivity and gain, and that group is called antenna array. So in the next lecture we will discuss on the horn, array and reflector antennas, and combinedly these all make a antenna subsystem that is called antenna subsystem of a satellite. Till then, thank you.